Okay, I'm going to work through the challenge problems here at the bottom of that logarithmic practice worksheet. My format looks a little bit different just because I wanted to give myself space to explain a lot more than what I'm expecting from you guys. Okay, now these first couple problems here asked to expand these logarithms. Okay, so putting it into individual simplified logarithms here. Okay, so if I look at this first problem here, all right, notice you've got exponents, you've got multiplication on the numerator, and you've got a division in the, and then you've got multiplication in the denominator. Okay, so the thing that I can tackle here easily is splitting that fraction up. Okay, so my first step here is going to split that fraction. All right, and I'm going to use parentheses a lot to try to keep things as clean as possible. But if we remember, in order to go in the reverse, to undo a logarithmic fraction, we have to subtract two logarithms of the same base. All right, so, and order is important, okay? Order is important. I have to have x squared y cubed minus the bottom because, again, that minus symbol tells me I'm going to have a fraction, and what comes next is going to be my denominator, all right? Now, what I can do is, if you notice, in both of those logarithmic expressions, I have multiplications, right? I have two variables inside there. So I can split those apart by doing my addition rule. So what this turns into is log base A of x squared. Oh, I don't know how that just happened. X squared. And again, this is a plus. All right, so if I were to put this in brackets, this first expression comes here. Log base A of y cubed minus my next expression. So log base A of m plus log base A of n. Oh, sorry, that one was a bracket, so let me fix that for you. All right, now the next thing I can do here is look at these powers. All right, I can look at these powers. And let me rewrite this here just a tiny bit simpler. X squared plus log base A of y cubed minus. Now, here's the thing. You can do this one of two ways. You can keep this in parentheses, right? Log base A of m plus log base A of n, or you can distribute that negative sign, because this negative parentheses log A of m plus log A of n, this is like saying -1 here, right? And this -1 is multiplied by both factors in my parentheses. So technically this is minus log A of m minus log A of n, right? Either way you want to take that back half of the equation is appropriate, okay? So I'll leave it in parentheses for right now, just for the sake of simplicity, all right? Now, if I notice here in the front half, I have exponents, okay? So the last thing we're going to do is we're going to use that power rule. So that brings those powers out in front. So this turns into 2 log base A of x plus 3 log base A of y minus what is in my parentheses. And technically that is done, right? If I told you there should be no parentheses or brackets or anything, right, in your final form, then we would do that distributing of the negative sign. So my official final answer would be 2 log base A of x plus 3 times log base A of y minus log base A of m minus log base A of n. And this would be your final answer. Right? Again, all we're doing is using our rules for logarithms, but in the opposite direction. right? So we're using them in the opposite direction in order to expand this equation. Okay. Now, looking at this next one here, right? Log base 3 square root of 5a to the 7th. Okay, so if I treat this here, that is my entire argument, right? So this can easily, right? I can easily turn this 5a to the 7th into a fraction, right? 1/2 is square root, okay? So this, if I raise this my entire radicand to the power of 1/2, it's like saying the square root of that radicand, right? Now, since we have an exponent and a logarithm, I can bring this out in front in my next step. So I have 1/2 times log base 3 of 5a to the 7th. Okay? So there's that. Now, next step here, okay, next step is I can then separate out my 5 times a to the power of 7. Okay? So what I'm going to do, since this 1/2 is a coefficient, it gets put on the outside of the parentheses when I expand this log, because again, this 1/2 acts on the entire logarithmic expression. So this turns into 1/2 parentheses log base 3 of 5, and it's multiplication, so I'm going to add my logarithm. So log base 3 of a to the power of 7. All right. Now, one more step here before we address this coefficient out in front. I have an a to the 7th. So again, I can do my power rule and bring that out front. So I have 1/2 of, I'm not touching that first logarithm, plus 7 log 3 of a. Okay. Now, again, this is a completely acceptable answer unless we want to take it one step further or you're told that there can be no parentheses. So again, this coefficient acts on both of those, right? That distributive property. So this becomes 1/2 log base 3 of 5 plus 1/2 times by 7, or 7/2 log base 3 of a. And that gets me to my final answer here. All right. And then finally, the last problem here in our expounding is log base 2 of b over c raised to the power of 4. Okay, so there's multiple things going on here, but first and foremost, let's take care of that exponent. So this becomes 4 log base 2 of b divided by c. Now again, we can separate this log base 2 of b over c by using our subtraction rule, but we got to remember that 4 acts on both of them, so we have to put that outside of our parentheses. All right, minus, because it's a division sign, log base 2 of c. Yes, again, order is important. It has to be b first, then c, because it tells you numerator, then denominator. Now again, to get rid of that parentheses, we use our distributive property. This becomes 4 times log base 2 of b minus 4 log base 2 of c. And again, that is my final answer. All right, that's if we were asking to expand these logarithmic expressions. Okay, most of the time we're going to be asked to condense or to make it into a smaller form. And this smaller form that we're looking at here is a single logarithm. So looking at my first expression here, okay, there's a lot of things going on and there's multiple places that you can start. I'm going to try to pick the most efficient way to address this problem here. Now, first off, I have coefficients, and we should know that those in the reverse direction become our exponents. So this turns into log base 5 of x squared plus log base 5 of y to the 5th. And I'm going to keep that in my parentheses for right now because that is going to be important. Okay. Now here, if I look at just inside my parentheses, I have an addition, which means that I can use my law of addition and turn this into a multiplication problem. Okay, I can turn this into a multiplication problem. Again, I can't forget the back half of my expression. All right. Now, what this looks like if I get rid of some parentheses and do that multiplication. All right, what this looks like here is the following. All right, and now it's very easy for us to finish this problem off because we have a subtraction, which means we turn this into our fraction since they have the same base value. X squared y to the 5th over z. And again, that's going to be my final expression here. Okay? Final expression. All right. If I look at my next problem here, okay, it looks very, very similar. Starts off the same way. So I've got to get those coefficients as powers, right? So I'm going to turn log base 7 of m, has that 3. Log base 7 of n to the power of 12. I'm going to keep that, of course, inside my parentheses, but it actually looks like the one outside as well has a power. Okay, so that becomes to the power of 3. Now, addressing my inside, my parentheses. Again, I have an addition. This is going to become a multiplication. All right, and for the sake of time, I'm going to skip a step here. Okay. Then, once we do the addition problem, we are going to do a subtraction-based problem. So again, the subtraction then turns this into a fraction, with the first part being our numerator and the bottom part being our denominator. So I have m to the power of 3, n to the power of 12 divided by p cubed. All right, and that becomes my final expression here. All right, and then finally, the last one here looks slightly different, okay? Looks a tiny bit different. You could take this multiple ways, but the way that I'm going to suggest is addressing the parentheses first. So I'm actually going to leave that 1/3 on the outside of this expression for right now until I can get the inside to be a single logarithmic expression. So I'm going to take that coefficient and turn that into a power plus log base 2 of t. Right now that I have those as a power, I can now use my addition rule, which multiplies my 2 arguments. So this turns into log base 2 of s4t as my middle argument. Okay. Then all I have to do is get rid of the parentheses because I have 1/3 log of s4t. Okay. Now I can simplify this one more step here. Notice I have I have a coefficient which I can turn into an exponent. So if we do one final step here, log base 2 of s4t to the 1/3. Okay. This is completely acceptable. Again, unless I asked for no parentheses, then we would have to do one final step. Turn that argument into a cubed root of s4 times t. Okay, so that would be my final answer there. All right, and that is essentially the hardest problems you will see about logarithms in this course. Okay, or something similar to that there. All right, let me know if you have any questions, and then we'll just keep rolling right along. Thanks, guys.